YouTube, this is a certain video in response to a gentleman who asked about the wiring connections in a model CG16.5 Hunter fan I had. It's sort of a government, what they call government model Hunter fan. It was about 1960, between the late 50s and somewhere later on, even into the 70s. So he had acquired one and wanted to know what the wiring was because it wasn't having good speed discrimination. So hopefully this will help. Now the diagram, I'm going to just leave it here for a video here for just a moment to be able to, so if somebody could, if they want to, freeze the video and see that. And then moving down a little bit more, see that, including the capacitor. I'll pull back just enough to see the whole thing at once and get the idea of how the wiring works there. So I'll go through it, and I'll go through it in detail in just a moment. Okay, we'll do the line and the head wire. The line is the cord from the plug. Head wire is the wire going from the motor to the base. Line wire. First up is the ground. Easy. It is connected to one of the screws that holds the speed coil, which is the thing that helps the fan change speeds, towards the rear of the fan. So the next one would be the neutral. It's a white wire coming in from the line, and all simply on this model, it just has a wire nut connecting it directly to one of the head wires going up to the motor. So that accounts for one of the four wires going to the motor. 3 from the line, 4 to the motor. The next one is the hot. You notice that the hot goes from the line, goes directly to a terminal on the switch. And that switch terminal is that one down there with the black wire at the bottom, exactly opposite the 3 connector terminal on the switch. So that's where the hot from the line goes. That takes care of identifying them. For the head wire, the wire going out to the motor, we had one accounted for already. The neutral is directly to the line. The next one, we'll do the green. We'll do the other 3 in left to right. Green. Its ground wire for the motor is simply that connection on the fan base. So the motor has a problem, short, whatever. It gets the ground current. The current will go through that terminal to the base, and then turn that to the other ground wire, transfer it to the household system. So that's easy. The black wire to the motor is a wire, one of the wires going to the 3 connector position on the switch. So that would be that top position. The one of those is the black wire that goes directly to the head wire up to the motor. The red wire, the final one for the motor, so we've lasted of the 4, just simply connects to one of the terminals of the capacitor, and that's a Cornell Dubelier capacitor. They made capacitors for Sunbeam mix masters, the real mix masters that have the mechanical governed speed. Very famous in that model. One terminal, it doesn't matter which terminal, it's an alternating current capacitor, so it could be connected to either terminal. The black wire, so I don't want to get ahead of myself, we can say that accounts for all wires for the line and motor. The capacitor, the other capacitor wire, while we're at the capacitor, goes back up and connects to that 3-position switch. So that's where there's multiple positions on that switch. So we've accounted for all the line wires where they go and all the head wires where they go. What's a little more complicated, it's not complicated connection-wise, but it's hard to see in the physical fan because of that spaghetti going on there. But the speed coil, remember we've got on the top 3-position terminal, we've accounted for the one goes to the capacitor, one goes to the head wire. Now the 3rd wire of that 3-terminal connector goes to the what I will call the right side of the speed coil when the fan's in this position with the pointed part of the base to the left. And there's 2, it's hard to see, but if there's 2 different wires going to that right-hand side of the coil, what I call right hand, that wiring there, that greenish wiring to the right. And that's what's shown here. So all 3 terminals of that 3-terminal switch are accounted for now. The motor wires and the line have been accounted for. The other two terminals also, which we haven't talked about, which is the right and left terminal on this diagram at the switch, that's that one and that one, are involved with the speed coil. One on the right of the switch, which is to the right of the, or clockwise to the 3-terminal connector, goes to a black wire that goes very close to the red wire that we talked about just a minute ago. And then the greenish black wire goes to the other terminal on the switch. And I call it greenish black. It might be green, but it's probably some sort of green, but because of the age, it could be black. It's that terminal right there, directly in front of the camera right now. Just 90 degrees counterclockwise to that 3-terminal connector. And that goes to the other side, the left, quote, left side of the speed coil. And that's it. That's how this fan is wired. It's a little complicated. I don't understand it. I know 90% of how this thing works. It's a permanent split capacitor model. It's a very good motor. They use this capacitor. This is now history, not wiring. This Emerson, or I think it was Emerson, pioneered the use of this kind of motor that involves a capacitor needed to run all the time. So if you're not getting good speed discriminations, check that your capacitor is about, this or a little bit higher is fine. Don't get away from using one a little bit lower. So you go 1.5, 1.752. Notice how large it is. It's nowadays this capacitor for the, and by the way, on 120 volt circuit, it doesn't say on this capacitor here, but you want it to be rated for at least 160 volts because it has to account for the peak voltage in the alternating current cycle. In America, where they use 120 volts, that's about 168. So 170 or 200, even 200 volts is good for you. So you got, when you get a voltage specified on a capacitor, it's almost always, that I understand, the peak voltage is the maximum the capacitor will be exposed to. And then the microfarad rate, that's 1.75 microfarads. A lowercase Greek letter mu is common. So I think I put that down here. You can express it a couple different ways, microfarad or that mu letter F by itself, or just spell it out, microfarad. So Emerson claimed that the capacitor that really took up their entire base on their fans would last longer than the fan. And this kind of capacitor seems to hold up to that theory. This is an old capacitor, and this fan runs just fine. So, but it could be bad, so that's one thing to check. And then the motor, make sure it's well lubricated. The motor, bearings, flush them out with 3-in-1 oil. Just overdose on 3-in-1, let it leak out, get thrown out. Just keep pumping that fresh 3-in-1 oil through, or some other fan motor oil. Even very, very light motor oil will work. The detergent action of the oil will flush out the bearings, which are basically the steel shaft of the motor's rotor, and bronze, brass, or some other metal bearings. And man, when they're flushed out, this thing spins like just very easily. So check those two things, capacitor and motor, that there's no drag practically on the motor bearings. Although this model with the light blades lighter than the Zephyr will come to a stop faster than a Zephyr, and of course you got to account for the drag of the motor of the gearbox when it's driving the oscillation. Oh, and a gentleman also wanted to know about that. That is the shape of the arm. It's probably common to so many fans. Sorry, the phone cut out. You're looking for an arm that's about just about exactly 3 inches from the center of the mounting to the center of the mounting, with a slight kink in it. So hopefully that helps with the arm. I'll have to put this section in the video, edit them together. Anyway, that's the whole story on this fan. If you need more information, just leave a comment. Thanks.